Welcome everybody to week 14, day number 1 out of 2. Friday we don't have any class, so don't come here on Veterans Day. I won't be here. So what we're going to do today is we're going to learn something really cool. We're going to learn new data structures. So CSI 41 is the data structures class where you're going to learn all of this stuff in excruciating detail, fun detail, but thoroughly, I should say, not excruciating because it's fun. It's thorough detail. Today you're getting sort of like a one-day preview of computer science data structures. And so you're going to learn my favorite data structure of all time, the Hash-and-Nappy. So let's talk about data structures. So the data structure you know right now is a vector. So what is a data structure? It's a way of holding lots of variables at once. Okay, so a vector, you can make a vector hold 1,000 integers, let's say. Vector of integers, or let's make it a vector of strings, why not? And we'll call this wedding list. There's a list of people invited to my wedding, and it's going to start off with size 0, and we'll do something like a while true loop. And we'll do something like this, string s equals read, add a person to your wedding list. And so if s equals quit, break, our standard while true break pattern, right? And then we'll say wedding list dot push back s. And then after we've brought all these things in, we will say for every string in the vector, see out the string. Yep. Are you guys comfortable with this? Sorry, it's not called vec, it is called the wedding list. Are you guys comfortable with the code we got here? So this is a standard pattern. You start with an empty vector, you read one string in at a time, you add it to the end of the vector, and you keep going until you're done. And then when you're done, you break, and then we're just going to dump the vector to the screen. This is stuff we've gone over repeatedly. So we'll add in Bill and Bob and Tim and Tom, and Tim twice, and Tom, and there you go. So you can see the names come out in the order they went in. Okay. So vectors. So let's talk about vectors. So the basic things, basic operations on a data structure are insert, search, delete, and I guess size to know how many things are in it. So how do we add things to a vector? We use pushback. But what if we wanted to add something to the beginning of a vector? What if we wanted to push front? Is that a function? Can we add something to the front of a vector? No. We can, but they don't make it easy for you. And so the reason why they don't make it easy for you is because it's not fast. So if you have a million things in a vector and you want to add something to the very front, do you know what it does? Answer now. Operators are standing by. What happens if you want to add something to the beginning of the vector instead of to the end of it? Do you know what it does? Yeah, it moves everything to the right one. So if you have a million people in a vector and you add something to the front, how many operations does it have to do, roughly speaking? So if the size of the vector is n elements, we always use n for some reason. The same way we use I for a loop. We always talk about the size as n. So if you have n elements in it, how long does it take to insert at the front? A million. Yeah, and so we call that an order n, or order n, or linear time operation. So it's order 1 or constant time, which means it takes like one operation, we'll say, even though under the hood it might be more. So push back is order 1. It just takes one operation, let's say, to add something to the end of a vector. Adding to the front is order n. Does that make sense to you guys? Does that terminology, it's terminology we'll discuss more next semester, but like, does that kind of make sense to you? Like if we have a million people in the vector, to insert at the front, you have to move a million people to the right. So it's the running time is 1 million or 1 million operations, or it's the running time is proportional to the number of people you have in there. But conceptually, does that make sense to you? And that's why push front doesn't exist. Because what they want is for people to be like, why can I not push front on a vector? And then you Google it, and then on Stack Overflow, it's like, you should not be using a vector if you want to push things to the front. If you want to push things to the front, there is a new data structure called a Deque. Okay? So, our list of data structures that we know is going to grow. 1, vectors. 2, Deque. Okay. So we're going to include Q. You caught up? You caught up? Okay, cool. And we're going to change this vector here to a double-ended Q, also called a Deque. And so a Deque is a vector where you can push front and pop front in order 1 time. Okay? So a Deque is just like a vector. Like a vector, but order 1 push front and pop front. So, what is the downside to a Deque? Okay, because there's kind of an obvious question here, right? Like, if a Deque is just better, like, why don't we just use a Deque for everything? And because the answer is vectors are 20% faster than Deques. That's the answer. So C++ has a policy of don't pay for what you don't need. So if you don't need push front and pop front, then you're going to be paying for it if you use a Deque, right? Like you're just slowing yourself down if you're not using a vector. So if all you need are push back and pop back, then use a vector. If you need push front and pop front, then you use a Deque. Does that make sense to you guys? So that's why vectors don't have push front, because they want you to Google it and be like, oh, there's a better alternative called a Deque. That's it. That's literally the only difference. Like, all the rest of this code will still work. In fact, did you see all it took for me to change was I changed the word vector to Deque. That's it. I now have a vector that I can now push and pop off the beginning. Do you guys understand the trade-off? Like, if you don't need it, don't make a Deque. Okay, so we're gonna add Bill and Bob and Tim and Tom, and there it is. Exact same code, right? So, all right. So we added it twice, right? So we got Bill and Bob and Tim Tom. So we inserted at the front and the back. We inserted at the front and the back. We inserted at the front and the back, right? So we have this weird symmetrical output here, right? Because we added both the front and the back. So it's like a pearl growing outwards or something. Okay, that's pretty easy to understand. That's really it for Deques. Like, if you need the ability to add things to the beginning of a line, use a Deque. If you don't, use a vector. Okay, cool. Any questions about that? Put them in chat. I think it's pretty straightforward, honestly. Like, you guys could write this today, right? Like, give me a thumbs up if you think you could use a Deque instead of a vector. You change vector to Deque. That's one word different. You have to include this. Okay. You have to include the right thing too. That's it. It's not hard. I'm sorry. I wish I could make it harder for you, but it's not. It's really not hard. Okay, so the next thing we're going to talk about is the notion of a unordered set. So this is a little bit different. It has no order. In other words, it doesn't remember what order you added things in. Okay? So an unordered set Thank you. All right. Okay. So an unordered set is a little bit different. There is no push back and there is no push front because there is no front or back to a set. When you have a set of names, something is either in the set or it's not in the set. So there's actually a set class and there's also an unordered set class. which does not preserve any ordering. And so there is no push back, there is no push front. Instead, there is insert. And it is an order 1 insert. And it just says we've seen that person before. And so we can do things with it, like we can do a search with it. So for example, what if we had seen the person before and we don't want to have a duplicate, right? We could do something like this. We could say if wedding list dot contains the name you just typed. We've seen this person before. Then we could see out, sorry, that person is already on the list. And just continue. You guys understand? So unordered sets have order 1, insert, search, and delete. It takes a single operation, conceptually. Again, under the hood, there's probably some adds and subtracts and things like that. But conceptually, it is a single operation. It does not take any longer if you've got a million things in there already. It takes a single operation to add somebody to our wedding list, and it takes a single operation to search it to see if we've seen George Foreman before, you know, to see if they're on our list. How long does it take to search a vector? So vector, how long? Like you got this wedding list and you want to know if George Foreman, Kanye, whatever, is on the list already. How long does it take you? If you've got n elements in your vector, if you've got a million names, it's the world's largest wedding. You've got a million names in your wedding party, and you want to know if Kanye is in there. How many operations, how many names do you have to check in order to see if Kanye is on the wedding list already? Yeah, a million. You're right. So vector search takes order n time, okay? Because you just have to go through all the names. Like, okay, it's not Bill, it's not Bob, it's not Tim, it's not Tom. And you just go through the whole thing. Now, if the list is sorted, then you can, you know, make that better. But if you just have a list of names, you just kind of have to look at them all, you know, and just be like, nope, Kanye's not on there. I went through all a million names, it's not on there. And there's no really faster way of doing that. Okay. Yeah, you have to go through n of them. Does that make sense? So unordered sets, though, can find out if Kanye is on the list already in one operation. So if you have a billion people on your wedding list, you'd be like, hey, is Kanye on the list? Yes. Got a trillion people on the... Hey, is Kanye on the list? Yes. That's it. Pretty cool, huh? Pretty neat. So the functions for unordered sets are called not pushback because there is no front, there's no back. It's called insert. And then if you want to search it, it's called contains. With a vector, you could use like find or something like that. Vector.begin, vector.end, and it loops over. For an unordered set, you just say, does it contain Kanye? Yes or no. And then you can erase something as well. So like, if you wanted to like get rid of your evil auntie off your wedding list, so wedding list dot erase evil auntie number 1 YYP. Obviously not speaking from personal experience here. All of my aunties, all one of them, were wonderful people. So we're going to try erasing evil auntie 1 and evil auntie 2. And that's delete. Okay. So unordered search, and that takes one operation too. To delete the evil aunties off of your wedding list takes one operation. That fast. Are they in there? One operation. To add them, one operation. To delete them, one operation. That's why they are my favorite data structure. Vectors are my vanilla ice cream data structure. If I just need to hold on to a bunch of you know, Pokemon or something, you know, I'm just gonna probably slap them into a vector to begin with. Like that's just my go-to. Vectors are really easy to use. They're simple. Like they're just like my generic. Like I need to will a bunch of variables. I'm gonna use a vector. But unordered sets are fast. They're really, really fast. And after you finish Pokemon Part 2 will It doesn't have to use an unordered set or an unordered map, which is what we're going to learn next, but it helps. It's nice. But the assignment after Pokemon Part 2, we're probably going to do a coding competition. And for that one, there's the first, I think this is actually the first, it'll be the first homework you'll have where running time matters. And if all you use is a vector, you're going to fail 2 or 3 of the test cases. Because it's going to be looking up people. Hey, have I seen this person before? And if you use an unordered set or an unordered map, which we're going to learn next, order 1 time. If you have a vector, it'll take maybe a minute to go through all, the different names in the database. It's like when you go into the DMV, right? The DMV, they type in your name to look you up, and it takes 5 minutes to find you. So I'm not going to kick Kanye out of the wedding, dude. I want to see what happens. So, all right. So vector search takes order in time. Unordered sets take order 1. Insert search into. Okay, so let's try this out. So we've got here code that will read in a name. If it's a duplicate, we say, hey, they're already on the list. Can't add them twice. Type and quit. We break out of the loop. We add them to the wedding list. Otherwise, we purge the list of anyone named Evilanti 1 and Evilanti 2. And then we're going to print out the remaining list afterwards. So let's compile it. Let's run it. And we're going to add Bill and Bob and Tim and Todd and Evil Auntie 1, Evil Auntie 2. I'm trying to make sure Auntie 1 with all caps isn't going to match, right? And of course, we have to add yay. Okay. So, and then quit. All right. And so you can see with an unordered set, the names do not come out in the order that I typed them. That's why it's called unordered set. Right? They're not in any particular order. Like Ye was last and it's first here, and then Todd's in the middle somewhere, and then Bill is last, was first. Like they're not, there's no correlation between when you type them in and the list you get out. Okay. Does the order always change? It doesn't have to. You might happen to get lucky and have them all in the same order, but you can't rely on it. It's called unordered set for a reason. It's an unordered set because there's no ordering. Now, if you want them always alphabetized, there is another one called set, which I don't use as often. Always ordered alphabetically in this case. And unordered sets, a ordered set have order login time. And so login time means for every doubling of the problem size, it does 1 more operation. That's actually pretty fast. So like the login of 1,000 is like 10. The login of 1,000,000 is like 20. The login of 1 billion is like 30. The login of 1 trillion is like 40. So if you have like 4 billion names, 4 billion names in your wedding list, and you want to find out if Kanye's on there already, it will take 32 operations-ish. It's not too bad. It's not fast. It's pretty fast. Login is pretty fast. Like, you've got 4 billion names in your wedding list, and you can find it in like 30 operations. Any modern CPU can do it like that. Like, that's, really fast. It's not as fast as order 1, but it's really fast. So, yeah, in the wedding reception staff setting up the live Kanye feed after kicking him out of the 1,000,000-person wedding. It's funny. Yeah, so this is really fast. And so if we just switch it, if you guys want to see what this looks like, this is going to be an enormously difficult refactoring. Set, okay, thank you. Okay, so if I want to change an unordered set to be a set, what do I do? This is it, people. If you can do this, you can survive in CSI 41. What do I change to change an unordered set to a set? Delete 2S. That's a good one. I actually was gonna go at 10x. Yeah, DTS is probably better. Cool. All right. Yeah, I think that worked. So now we have a set. And so a set is an ordered set. And so what is it ordering by? It's ordering by alphabetical order. So it's not the order that they were typed in. It's ordered by alphabet. So if we type in Bill and Bob and Tim and Todd and evil Auntie 1 and evil Auntie 2 and good Auntie and Yay and Kim Kardashian there, you will see the names we get out are in alphabetical order. Okay? So a set doesn't preserve the order that you inserted things. It a set of integers is ordered from smallest to greatest, exactly. And so sometimes you need that. I don't usually need that. Maybe I do. I don't know. It comes up, I guess. It's not something that I'm not going to say you don't need to know. Yeah. But usually unordered set is what I use. Why is the list coming after quit missing names? Is it? Why is the list? Oh, because I still have the erase in there, right? So we're still erasing evil Auntie 1 and 2 from our wedding list, right? Because we do not want them at the wedding. Like, they're going to complain, and I understand, but I'm sorry, there's only room for 80 people at the wedding, and, you know, we had to prioritize my Taekwondo friends. I'm sorry. Like, it's just, you know, there's only 40 for the groom, 40 for the bride. My wife's got a big family. Like, I'm sorry. There's, you know, we wanted you here. We did, but, like, we can't. There's just no room. And besides, it's a long drive from you. So, like, I'm sorry. You can send us a gift if you want. We'll send you a thank you card. Okay. So, yeah. So if we come back in here, you can see that we are erasing evil Auntie 1 and 2. And so that's it. Like, literally, that's all you need to know. The only other thing that we might want is, like, something like this, like, see out your wedding list has... Anyone want to guess what the name wedding list? Anyone want to guess what the name of the function is to get the size of the wedding list? Mean Girls. If two of the strings were the same, but one was lowercase and uppercase, does it count as upper? Yeah. So yeah, alphabetizing is weird when it comes to uppercase and lowercase, right? Because lowercase numbers are larger than uppercase numbers, so you're going to get all the uppercase letters first, then all the lowercase. And so if you want to, like, not deal with that, like, alphabet, like, that kind of issue, typically you'll just uppercaseify everything and then just sort on that. Size, yeah, it's wedding list.size. It's literally the same thing for every data structure. And so now if we do this, and yeah, so to answer Megan's question, if we have person AAA and lowercase AAA and ba and ba and ba and ba, then you can see it alphabetizes the uppercase letters first. So, like, an uppercase comes before lowercase. It's weird, right? It's just kind of weird. So, I mean, it makes sense if you understand the ASCII table, right? Like, the ASCII table, you can actually literally look at the value of A. A is 65, lowercase a is 97, A is less than 97. Like, it makes sense. It's just kind of weird. So, uppercase letters have a lowercase. Yes, that's exactly right, Aiden. The ASCII values for uppercase letters are lower than the values for the lowercase of a higher value. Lowercase, higher value. Yeah. So if you want to not deal with that, C++ isn't I18N. What do you mean by that? No, this is ASCII. This is definitely just ASCII by default. C++ does support what are called wide strings, which allow you to do Unicode and things like that. But Unicode's weird to deal with. It just kind of is. Like, there's no concept of, like, a character. Instead, you have, like, these concepts called, like, code points. And, like, code points can, like, merge together and things like that. So it's actually kind of hard to tell how many letters you have in a word in Unicode. So for this class, we just stick to ASCII. Yes. But yeah, like, if you wanted... no, I mean, C++ does support Unicode. Like, don't get me wrong, but, like, W string. Make this a W string. That's not a double. It's not a wide string anymore. You know, so like it's just kind of a pain. But yeah, it supports Unicode. You just have to use a wide string instead of regular string. Regular strings are ASCII. Wide strings are Unicode. So I mean, it already supports it. And if you want, you could see out. You know. Let's see here. Diamond hands, straight to the moon, you know. New line, like you can do that. That's fine. Compiles just fine. Runs just fine. There you go. And so we can add ABB and ABB and ABB, and etc. And you'd see it just alphabetizes with ASCII. Okay. So, good question. Very good question. Not too bad, right? Like, not too bad. Set, unordered set. Makes sense. Sets are always alphabetized, always. No matter how you insert, search, and delete them, like they're always in alphabetical order. Unordered sets, who knows what order they're in. That's why they're called unordered sets, but they are super fast. And so unordered sets are great for your standard, like, database things. Like, I want to save you into the database. I want to see if you're in the database. I want to delete you from the database. I want to restore you from the database. Load from the database. All of those are single operations. Super fast. So, pretty much all follows from what we've learned before. Why are they fast? You'll find out in CSI 41. Like Voss in the 12 o'clock class. Like, how can you, like, if you have a billion things, how can you search through a billion things in one operation? How is that possible? And I'm like, take CSI 41. He's like, is this a DLC? Is this like, you know, a day zero DLC for CSI 40? It's like, no, like, I'm just giving you guys a preview of 41 right now. It's actually an entire lecture in itself, and we need to talk about Pokemon Part 2. So, you just please know now. Look up hash tables if you want to know how they work. Hash map. So, next up is what we're gonna do for Pokemon Part 2. So I'm just gonna comment stuff out. And what we're gonna do now is an unordered map. And they also have order 1, insert, search, and delete. You in there, and we'll just send you guys off to the code graveyard. Out of sight, out of mind. There we go. All right. So what is an unordered map? An unordered map is called an associative array in some languages. So you can do something like this. You can say like unordered a map from string to integer named calendar. And then you can do something like calendar square bracket janvier equals 31 and calendar février equals 28, maybe, sometimes. And Mars is 31. I'm sorry. March, Avril. Is 30, and so on and so forth. Okay. So you can, so the notion of an associative array is that the key, the index value in the square brackets there doesn't have to be an integer. Here it is a string. That's what that type there means. It means the index type is a string. That's called the key. The key is what you use to search the database. This is called a key value pair. And this is an extremely important concept in computer science. And if you do any work in databases and things like that, it's all over the place, the notion of a key. A key is what you use to search a database to find information. Typically, when you are looked up in a database, they use your social security number is used to look you up. It's used as the key because all social security numbers are unique. It makes for a great key. And it's illegal to do so, but everyone does it anyway, so nobody cares, I guess. So we're going to look up the calendar value for January. And you see, I'm not using a number in there. I'm using a string. That's this type here. And the value that I'm saving in that location is the number of days in January. So the number of days in February is 28. Number of days in March is 31. Number of days in April is 30. And then I can, this is insert, right? And this is order 1 insert. And then we can have order 1 search. This, I'll capitalize the insert just to match. And so if I see out the calendar of, I don't know, March, what is this going to print to the screen? Everybody? 312. Interesting. Probably typo. Yeah. Good. Yeah, it is 31. Well done, Ben Court. Okay. So so it's going to look up in the array. It's not an array, but it acts like an array. It's going to look up the value of March and print out 31. What if I were to look up the value of May? What is this going to print out? This is one of the sharp edges when working with unordered maps. Out of bounds error? There are no boundaries. Remember, there are no actual... This isn't like an array. It's not like a vector. It just goes into some database in the sky. And if you try loading a value that's not there, it'll do something. Yeah, Alessandra has it right. It prints out 0. Okay. Arguably not what it should do. It should arguably throw an exception, right? So we're trying to load a value that doesn't exist. But here's the wild thing. So whenever you work with a unordered map, always deal with key value pairs. Okay. So in this case, the key is January. The value is 31. But if you like want to print out all the values in an unordered map, you have to do this. You have to say for every const pair of strings to integers named p, because it returns 2 values, it returns a string and an integer at the same time, which is annoying to deal with. This is maybe too advanced for you, but I don't think so. I think you guys can handle this. So for every for every key value pair, that's what it's saying. For every key value pair in the hash map, if you guys don't get the reference, Betancourt, can you find the YouTube links? So there's the one guy who's like doing a job interview, and his senpai is like, just remember, if you ever get stuck, use a hash map. And then there's the Jomu Tech one where it's like programming is an anime, and he invokes the hash map. All right. So what do you need to memorize? Just memorize what? Does it assume it's initialized to 0? Yeah. So here's the problem. Let me show you what the problem is. Okay. So I'm going to see out p dot first, and you guys have never seen this before, so don't expect that you like forgot something. And p dot second. So it returns a pair. A pair is the world's most simple data structure. It looks like this. Struct pair, int, well, in this case it's what, a string int, string first, and int second. This is literally what is being returned here, right there. You guys understand? So it's returning a string called first and an integer called second. So for every entry in our calendar, it's going to return January 31, February 28. You guys with me on this? It's a little bit weird. And that's why, I'm saying it's maybe a little bit advanced for you guys right now. But there it is. Programming was in anime. Perfect. Okay. So what's this going to print out? How many months is this going to print to the screen? Would it print out January, February, March in that order? What do you mean by order? What is this order you speak of? If you want things in order, we could use a map instead of an unordered map. Then it'd be alphabetized. But alphabetizing the months, yeah, that's weird. April is the first month, right? August is the second month. Like, what? I don't see any benefit to that, to having it ordered by alphabet. Yeah. So it should, if this was a reasonable and sane universe written by, if the standard library is written the way that you think it should be, then you're right. It should print out 4 entries: January 31, February 28, March 31, April 30. Warning: loop variable IP. What are you mad about? Auto. There we go. Auto. Make it easy. So instead, we actually get 5 entries. Okay, open. Go ahead. We actually get 5 entries. We have an entry for May. Yeah, we didn't ever set the value of May. We loaded the value of May. But C++'s unordered map library has a really sharp edge here, where if you read a value that doesn't exist, it inserts it into the hash table and then returns it. So if you are loading a value that doesn't exist, it puts 0 in and then returns. Yeah, so there's a better way of adding things to a hash map rather than square brackets. Now, square brackets work if you're like in your Pokemon assignment, and the only thing you look up are the types, and the types are fixed, and there's no guarantee. There's no worry that you're going to type in a type wrong. Like, it's all in a text file. You know, fire is always going to be spelled with an I, not a Y. You know, that kind of stuff. So there is a better way though. Like if you're working with like user input, okay. And so you could insert things like this. Rather than calendar April, you can do like calendar dot insert April 30, like that. Insert key of April and value of 30. Okay, so sorry, I need double quotes there. There we go. So these 2 lines of code are the same, but it has no risk of like, well, it didn't anyway, but like this doesn't have, insert doesn't have the risk of square brackets, accidentally adding an entry when you didn't expect it. To do a lookup, like if you want to output the number of days of May, you could say if calendar dot contains May, because contains is a thing. If calendar contains May, then cout calendar dot honestly, you can just use square brackets at that point, but find May or something like that. Now that would return iterator. No, you just do calendar May at that point. So this is actually safe. Okay. This is safe because it can't insert anything into there because you've checked to make sure it's already in there. So if it's in there, you can output it. If it's not, cout May does not exist. So this is kind of the proper way of handling it. So you make sure it exists, and then you can just output the value if it does exist. If it doesn't, like you just don't want this to be unprotected. Okay. So just like vector square brackets work with possible bad side effects. Yeah. So a lot of C++ people poo-poo square brackets. I think the syntax is a little bit easier to read than this. Maybe it's not that big a deal either way. So. But yeah, anytime you use square brackets to read a value out of it, you should always combine it with dot contains first, like to make sure it's there before you pull the value out. Because if you don't, it adds it, which is utter garbage. It's absolute utter garbage. Okay, so cool. And so if we do this now, we will not get a spurious entry for May. May does not exist, right? And then we've got our four things in there. So we got four entries there. All right. So what relevance does this have to do with Pokemon? Okay. So Pokemon. Let me switch gears here. Pokemon Part 2, and I did have a student turn in Pokemon Part 2 for Pokemon Part 1. With code that another student submitted 2 years ago. So don't cheat. Like every time I grade homework, it tells me whose homework is similar to other people's homework, and so like just don't do that. Just don't. I'm not gonna make a big deal out of it, but just don't. Okay. If it continues, I'm gonna have to like, drop the ruler on people. Just don't copy other people's code. It's like I hadn't even given you guys part 2 yet. How are you turning in part 2 when you don't even have the assignment yet? Like it's like, don't do that. Okay. Who cheated? I'm not gonna name names, dude. Okay, so all right, so for Pokemon Part 2, the essence of Pokemon Part 2 is there is a file here called the type system. And the type system is a giant 2D vector that you're going to load that contains which Pokemon do double damage to which Pokemon. Technically, which moves do double damage to which Pokemon. So in Pokemon, there is this notion of Pokemon types. So so some Pokemon types beat other Pokemon types. Like leaf, grass type defeats water, water defeats fire, fire defeats grass, even though it's not on here. And so this graph here will show you, this is, let's say, the attacker. So if the attacker is using fireball or something like that, you have to go down to the fire row. And let's say a fire attack is hitting a rock type Pokemon. You go over to the rock column. Now, note that these columns are not numbers. This is not column 1, column 2, column 3. This is column fight. Do you guys see where I'm going with here with the associative array? And the column is not called column 7. It's called column ghost. So what you're going to do, and you don't have to do this. If the associative array, if the unordered map is too complicated for you, you can write a giant if statement. If attacker type is normal, row equals 0. If defender type is electric, row is 12 or something. Yeah. So what do you mean they're adding new types? Ooh, interesting. That's cool. Yeah, neat. New third Pokemon type. Cool. Has Terra types now for a third type. Very cool. All right. So anyway, so like let's say if you use a fighting move on a ghost, it does no damage. If you use the fighting type on a normal Pokemon, it does double damage. If you do fighting type on steel, double damage. If you do fighting type against psychic, you do half damage. And Pokemon can have 2 types, and so you have to take both of those into account. So if you have a fighting type hitting a flying poison type, the fighting type move does 1/2 times 1/2, 1/4 damage. But if you have a fighting type hitting a rock steel type, then it's super effective and does quadruple damage. So this is the type of the move, and this is the defending type or types of the defending Pokemon. Okay? So name all the fire type Pokemon. That sounds like one of those memes, right, Megan? Like, well, if you're a true Pokemon fan, name every fire type Pokemon. Like, do you know how long Pokemon Company has been making new Pokemon? It's been a while. It has been a while. They've been spinning out pun names for Pokemon. So if you are doing a grass move against a poison ground type, 1/2 times 2 is 1. And so it does normal damage. Okay. If you're an electric type hitting ground and water, it does 0. Because 2 times 0 is 0. Okay. Zooming on the screen. Well, it's this table here is this. I've already copied it onto the server for you. Okay. I've already done the data entry. And I think it might be tab delimited. Yeah, it's tab delimited already. Cool. So you've already got a copy of it on your computer. Now this is a partnered assignment, so you can have up to 3 people working on it together. You have to self-sign up. So on the on Canvas, there is a People tab, and you go onto the People tab, and you sign yourself up on there. Again, it's cheating if you have the same source code as people not in your project. And so when you do your project, you're going to put in who your partners are. Okay. This is not an auto-graded assignment. It is a free graded assignment by me. And so what you do is you can come into CSite 40, and then under the people tab, here, I'm not gonna show people's names online, but let's see. Snap it down so students' names are hidden. So you're going to click on Pokemon Part 2. Okay, that's the group for this assignment. Click on Pokemon Part 2 and then add yourself to a group with your friends. Okay, so okay, so what do you have to do? So you have to basically implement Pokemon battling. All right, so you have to select 2 Pokemon to battle using either the index or the name. So the user has to be able to type either Bulbasaur or 1, right? Because Bulbasaur is Pokedex entry 1. And then you select up to 4 moves for each Pokemon. They can use Flame Fist and, you know, Lightning Dash or whatever. Some students that are into Pokemon are like, wait, you allow any move for any Pokemon? I'm like, yeah, I don't care. Like, like if you want to give Hyper Beam to, you know, somebody that's not supposed to have Hyper Beam, I don't care. All right, like that's not the point of this assignment, and that would make things fine. It's blasphemy. If you want to implement it, like, go for it. It's way too complicated for this assignment, though. But if you want to, like, go right ahead. It's fine. Give everyone struggle. Yeah, it's like Mew in Pokemon Unite has all the moves. Yeah, and so basically you just pick any 4 moves. I don't care. All right. And then they're going to battle. So what's going to happen is you're going to pick 2 Pokemon. The one that has a higher speed goes first. It picks a move to do. It does that damage to the defending Pokemon. Some moves have an accuracy, and so there's a chance it misses. Like at 75% accuracy, there's a 25% chance it just misses. But if it hits, then it does damage. And so this is a algebra assignment, I guess. Like, we're kicking it back old school to like week 2 of this class, where you're going to do a lot of algebra. Okay, so they're going to pick like a move, like let's say they pick like Lightning Dash or something, or I guess Psybeam down here with a power of 65. So you take the power of the move, you multiply it by the attack power of the Pokemon, you divide it by the defense value of the defending Pokemon, you multiply in the stab bonus, which I'll explain in a second, and you multiply in the type modifier. And that type modifier is really the hard part of this assignment. So each row corresponds to a different type: normal, fighting, poison, etc. Each column corresponds to a type: normal, poison, fire, grass, whatever. And you have to look up the row for the attacking move and the column for the defending Pokemon. And if it has 2 types, look up both of them, multiply them together. That is your type bonus. That's a letter grade for doing that. Okay. So, see Bencourt. So if you want to see how that might work, I have a file that I've pushed out to all of you called Map Demo. And it's already got all of the names of the types and all of the rows and columns that they correspond to already in there. It's already in there. Just use that somehow to look up the row and the column in a giant 2D vector for the type system. Okay. So in the previous assignment, you had to load the Pokemon database, the moves database. For this one, you're gonna have to load the type system. Yep. And then when somebody says, I want to do a ghost attack on a psychic Pokemon, then you go down to row 7, column 13. If you have a normal attack on a fire Pokemon, row 0, column 9. Poison attack on a ghost Pokemon, row 3, column 7. Okay? Look up the value there and multiply it in. You guys understand? And this map here, you don't have to use it. If you don't want to use it, you can just write a giant if statement. So if the type is normal, return 0. If the type is fighting, return 1. If the type is flying, return 2. And this will map you between the type the type, and the row. If this is too confusing, you can just write a giant if statement. It's fine. It's slower, but it's fine. Okay. So what is stab? So if you have a fire Pokemon doing a fire move, it gets a 50% damage bonus. So if you have Charmander doing fire spin or something, then it does 50% more damage. And if you have a fire Pokemon doing lightning dash, lightning is lightning type, fire is fire type, they're not the same, then it just does regular damage. So if the types don't match at all, multiplier is 1. If either of the Pokemon types is fire and you do a fire move, you do 50% more damage. So that's it. That you have a week to do it from today. You can work on it in groups with a partner. There's extra credit available that I highly recommend you guys do. The extra credit is having an adventure mode where you can fight Pokemon and capture them and add them to your team and grow a Pokedex, a living Pokedex of Pokemon over time. And then another letter grade if you had a top-down map like you did in your RPG 40 assignment, where you can walk around and have adventures and capture Pokemon and stuff like that. So that's a letter grade as well. So you can get 120% on this for you and your partners. Part 2 is due 1 week from today. There's no class on Friday, so if you want help on this in class, work on it tonight and Tuesday. And so in Wednesday's class, if you have any questions about how, to look up the row and column, unordered maps, whatever, you can ask, okay? Because Wednesday is the last day. You'll have me around before it's due. It's not hard. It's mostly just algebra. So this is just algebra. This involves loading a 2-dimensional vector and, doing some row and column searches and things like that. It's not hard. This is just algebra. None of this is actually difficult. The extra credit's difficult. If you actually implement Pokemon, that's a lot. But the basic 5 letter grades is you should all be able to do it individually. Make sure you put down your partners. Again, I'm going to be a little bit more hard-nosed about cheating going forward. Write down which bullet points you did and write down how much extra credit you did. And that's basically our class for today. The set, unordered set, and of course, we'll add the last thing here, unordered maps between X and Y. That's the best way of putting it. Associative array. Okay, and so this is kind of a preview, like I said, for CSI 41. You're going to learn even more data structures in there, what they're good at, what they're bad at, when you should use them, when you should not use them, things like that. Just like how you learned today that if you need to push front, you should use a deck instead of vector. That's 41, essentially. And you're going to come out of that class knowing the standard library really well and learning more about programming classes and knowing data structures inside and out. And that class is really good for your development as a computer scientist. And even if you're not a computer scientist, even if you're not a computer science major at all, if you're in a field that requires you to take this class, you should take 41. Because if your field requires you to have a semester of programming, they do programming in it. And 1 semester of programming is not enough. It's like taking 1 semester of Spanish. It's like when you work for the State Department and they require you to take a semester of Spanish for your job. It's like, I'm suspicious I'm probably going to actually need Spanish and more than a semester. And if I only take 1 semester in my freshman year, I'm going to forget it by my senior year. So maybe I should take more. It's like that for 40 and 1. CSI 40 and 41 go together, and together are the Learn to Program series here. So, can you read my PM? I don't have a PM from you. Nope, I don't see anything. Once more Pokemon. Can you make a ROM hack? When does part 2 do? Okay. So that is our class for today. Thank you guys for coming out. I'll see you guys on Wednesday. And I hope you're fired up for 41 now. If you guys need groups, make sure you post on the chat channel. Get yourself grouped up. Or you can do it individually if you want. I'm not going to be a stickler on this one. Either way, either individual or solo or group. It's all good. All right. Peace out, everyone.